Mainly to the majority of countries suffers from marine contamination as a result of widespread waste disposal. As a result, several innovations have been made to address this issue. According to the Glasgow in 2016, 75% of land-based oceans plastics originates from the uncollected garbage that finds its way through waterways before reaching the seashore. The varieties that have been invented are inexpensive and simple to use, but the drawbacks of existing products are that they are not safe for use on beach due to the quicksand, need a lot of force and to drive the trolley, and do not have enough room to hold the garbage if we have a hand picker. As a result, we developed this tool to enhance the latest type of seashore trash collected and to assist people in collecting more garbage in a short amount of time. Then, in comparison to other types of garbage picker, the Seashore Rubbish Picker was built to support many purposes. So basically, in this project, we have three objectives. The first one is to determine the user requirement on the design of a Seashore Rubbish Picker. The second one is to design a prototype of Seashore Rubbish Picker based on the user requirements. And the last one is to develop and evaluate the functionality of the Seashore Rubbish Picker prototype.
The board that made by the wood to assemble all DC motor, Arduino wheels and wire that connecting among them. Brickboard. A brickboard or a protoboard is a construction based prototyping of electronics. And next I will explain about the function. Arduino Nano, the function of this component to produce a clock of precise frequency using constant voltage. Next is L2N motor driver board. Motor driver board regulate voltage from battery to Arduino and motor and distribute current to motor according to PWM of Arduino. Flash signal receiver to transfer signal to Arduino. Brushless motor to spin the tire. Antenna receive signal from transmitter. Press pad the structure of the car and hold the component. Breakboard holder of Arduino. Sweeper to sweep the rubbish into rubbish pan if rubbish pan cannot shove the rubbish. Rubbish pan transfer the rubbish into the dustbin and dustbin box to store the rubbish. How to function? Arduino program it using Arduino IDE. Motor driver board provide PWM signal from Arduino into the board and send voltage to the motor correspondingly. Flash receiver translate PPM input from the antenna into 6-channel PWM output. Entry of them will be sent to Arduino. Brushless motor connect with L289N. Antenna split the antenna wires perpendicular to each other to maximize receiver input. Press pad screw with other press pad to create structure. Servo motor connect with Arduino to receive servo input set its rotational angle. Brickboard to connect Arduino with another component. Sweeper connect with servo 5G to move the sweeper perpendicularly. Rubbish pan connect with servo 5G to move rubbish pan up and down. And lastly, tire. Connect with the brushless motor to give it power to spin. Why we need this part? All parts is related to produce one product that can pick up the rubbish. Thank you.
My name is AZYYATI binti AZHARI. I will explain for the engineering calculation. First, we calculate the shear strength of the plain wood. Shearing strength of wood is 10 to 15% of its tensile strength in the direction of the grain. Shearing strength is weakened by knots and faults and cracks appear in the wood. So, therefore, we calculate the shear strength of the plain wood and we got 0.02 Newton per centimeter square. It is important to make sure that the strength of the wood is high, which is to make sure that it won't break when we collect the rubbish. Next, in the case of bending beam, we are dealing with the modulus of elasticity and modulus of the rupture to evaluate its load resistance. MOE is a measure of the stiffness of the body, and MOR is related to the maximum strength that can be resisted by a member. Both are expressed as stress similar to the most of other mechanical properties of the wood. The following two equations are used to calculate MOE and MOR of the wood with rectangular cross-section. After we calculate, we got MOE is 48.29 Newton per centimeter square, which is smaller than the elastic modulus of the plain wood, which is 8.9 gigapascal, and MOR of 216.67 Newton per centimeter square and smaller than the theoretical value of the plain wood, which is 74.7 megapascal. So we assume that this wood is strong enough to be used in our product. The last part, we calculate the tensile strength of the polyethylene. We use polyethylene as our material of container because it has high ductility and strength impact. So to make sure that the polyethylene is suitable, we must make sure that the tensile strength is lower than the theoretical value of the polyethylene. So as we calculate, we got the value of 2.86 kilopascal, which is lower than the value of the theoretical of polyethylene, which is 40 to 58 megapascal. So we proceed with the polyethylene as the container.
Drilling is a cutting technique that involves cutting a circular cross-section hole in solid materials with a drill bit. The bit is pressed against the plain wood body for joining the motor and tires mechanisms. Screws has been used to join several parts to the main frame. Milling is the process removing material from a workpiece by advancing a cutter into it with a rotary cutters. The PCB board purchased is in bigger size, which is not suitable for the tiny prototype. Hence, it has to be rescaled by using milling machine as PCB board has delicate dimension and precise tolerances. Arduino microboard is chosen to control the movement of Seashore Rubbish Picker. A set of instructions is sent to the board via USB port. A servo motor is chosen to control the movement of the sweeper and the scoop. Welding process is a fabrication process that involves fusing two or more parts together using heat, pressure or both to form a joint as the part screw. It is used to join the servo motor to the base for the support system.
A cost analysis. The cost analysis the material we buy. The material we buy is plain wood, tire, sellotape, Arduino L2989 board, FLY Sky 60 receiver for receive the signal, 850mAh 3S LiPo battery, servo motor 5G, bushless motor, polystyrene press fed, breadboard, flash key transmitter for the sends the signal to the receiver. The material we buy all at the Shopee, and you can see at our report the place you can buy at the Shopee. All the item you can get it from there, and from there we can show the receipt. We purchase the item from the Shopee. And for the direct material, plain wood, tire, sellotape, Arduino, the item that I say for the first time is all about is direct material. For the indirect material cost, it's like a wire. We just using a 2-piece. of wire. Is I think 0.56 for 1 meter. And for direct labor cost, supervisor, operator and worker. For supervisor, will get salary per month is 2,100, operator is 1,500, and for the worker is 100, 2,000, and we have a 2 operator and 2 workers, 1 supervisor. So the total cost, the total amount will be for the direct labor cost is 2,500. For indirect labor cost, for the logistic 1 delivery per week, we using a lorry. So the salary per month is 1,200. And for the supporting staff like clerk and cleaner, we have a 2. So they receive a 1,200, and the total salary is 2,400, and the total indirect labor cost we have spent is 3,600. For indirect expense, for the utilities, for electric bills we pay 800 per month, for water bill is 500, and the maintenance for that building is 800. For the total cost for indirect expense is 2,100. For direct expense, for building rent is 1,050, and the assessment tax is 250. The total will be spent is 1,400. For manufacturing overhead cost, indirect material labor is in RM1.80. For indirect labor is 3,600, and for the indirect expense is 2,100, and the total will be 5,701 ringgit 80 cents. For the manufacturing cost, direct labor cost per unit plus with direct material cost per unit and manufacturing overhead cost per unit. For the direct labor cost per unit, we must divide by 400 because it's for 1 month we output will be 400 piece, so we need to divide by 400. And direct material cost per unit, we using the cost we make that we spend for the material, and manufacturing overhead cost per unit we divide for 400 for the 400 output, and we'll get the answer 425 ringgit 72 cents. So for the selling price, we take for selling price 30%. So for the manufacturing so the price of from selling price 30%, and manufacturing cost will be a price is 550.
So for the sustainability, we have 4 factors, which is the first one is the air acidifications. Sulfur dioxide, nitrous oxides, and other acidic emissions to air cause an increase in the acidity of the rainwater, which in turn acidifies lakes and sound. These acids can make the land and water toxic for plants and aquatic life. Acid rain can also slowly dissolve man-made buildings such as concrete. For this project, it has 0.09 kg of sulfur dioxide. Meanwhile, for the carbon footprint, it has carbon dioxide and other gases which result from the burning of the fossil fuels accumulate in the atmosphere, which in turn increases the Earth's average temperature. Global warming is blamed for problems like loss of glacier, extinction of species, and more extreme weather. And among others, there are 9.4 kg of carbon dioxide produced in this development. The third one is the total energy consumed. This impact includes not only the electricity or fuels used during the product life cycle, but also the upstream energy required to obtain and process this fuel, and the embodied energy of material which would be released if burned. In these projects, it involves hundreds megajoules. And the last one is the water eutrophications. When an overabundance of nutrients are added to a water ecosystem, eutrophications occur. Nitrogen and phosphorus from wastewater and agricultural fertilizers causes an abundance of algae to bloom, which then depletes the water oxygens and result in the death of both plants and animals' life. And this project, it have 9.0 kg of phosphate. So that's all.
The conclusion that we can get from this project is a seashore is our responsibility. Our product is designed for the Seashore Rubbish Picker. These projects can keep the seashore clean and can simply your work. We are achieve user requirement for using this prototype. The prototype, as you can see, they are pick rubbish on the floor, so the user do not need to pick up the rubbish. It design our product with ergonomic style.